Welcome to use the joint actuator developed by Sito company. It includes two parts. The first is to identify and eliminate the friction torque, and the second is to obtain the conversion coefficient from current to torque. These two parts enable the joint actuator to rotate easily even when connected to a large mass load. This feature package depends on the ROS noetic system. Users can install it by themselves. The package can be downloaded from our website. Before using the feature package, you need to download the dependencies. Here we use a new system for demonstration. Install Eigen. Install PyYAML. Install Serial. After the dependencies are downloaded, we can try to launch the single actuator.launch file first. This error is because the glibc version is incorrect. You need to download a higher version. Open the sources.list file and add the higher version source to it. Install libc6. Reopen sources.list file and delete the previously added content and update the source again. Relaunch the launch file. This is because the serial port does not have permission to use. Just give the serial port permission. Launch again. The program runs normally. After completing the preparations, open our feature pack. This feature pack has three functions. The speed friction detection function is to obtain the relationship between the current output by the actuator to overcome friction and speed when the actuator is unloaded. This function controls the actuator to rotate at different speeds and saves its continuous feedback data. Then the install lib on singles auto speed friction fitting file is used to fit the current and speed data to obtain the relationship between current and speed. The torque and friction detection function is to get the relationship between friction and output torque. This function requires installing a heavy load in the output side of the actuator and then record the change of friction current when the actuator outputs different torques, and then use the torque friction fitting file to fit the relationship between friction current and output torque. The torque identification function is to get the relationship between friction and output torque and verify the final effect of friction parameters. Change the friction parameters in small increments according to the actual situation. Before executing the program, you need to change the acceleration and deceleration of the actuator to 6000 and configure the single actuator.yaml file. Change the feature parameter to speed friction detection and run the torque control.launch file. It takes about 16 minutes to complete this function. It should be noted that if the record path does not exist, the CSV file for recording data cannot be generated. At this time, no items can be assembled at the output side of the actuator, otherwise the test results will be too large. After the actuator stopped rotating, close the program, configure the speed and friction to fitting YAML file, then run the speed to friction to fitting file. This file will output the 7 friction parameters of the E actuator related to speed. Fill these values into the frict param parameter of the single actuator.yaml file. So far, function 1 has been completed. Then function 2, refer to the picture shown. Add a heavy weight to the actuator, where the connecting rod should be in a vertical downward direction. The overall center of gravity of the weight should be on the connecting rod. And modify the zero offset parameter to set this position as the origin. Change the feature parameter to torque identification and launch the torque control.launch file again. This function will lift the weight and detect the output current. Calculate the torque applied to the actuator by the counterweight. Due to gravity, divide the theoretical torque value by the current value to get the current to torque conversion coefficient, and write the coefficient to the cur-tor-fastor parameter in the single actuator.yaml file. Change the feature parameter to torque friction detection and run the torque control.launch file again. This function will run for about 4 minutes after the actuator stops. Close the program. Configure the torque friction fitting.yaml file and run the torque friction fitting file. This file outputs the relationship parameters between friction force and output torque. The parameters are divided into two parts. The direction of rotation is the same as the direction of output torque and the opposite, with two parameters in each part. Write these parameters to the corresponding locations. This function 2 is completed. Then start feature 3. Change the feature parameter to torque identification and launch the torque back control.launch file again. Then, according to the actual situation, you can adjust the last element of frict param assist, frict param resistance, frict param assist neg, or frict param resistance neg parameters appropriately. If there is no abnormal situation, there is no need to adjust. For example, if the actuator decelerates significantly when the rotation direction is the same as the torque direction, increase the frict param assist or frict param assist neg parameter, otherwise decrease it. If the rotation direction is opposite to the torque direction, adjust frict param resistance or frict param resistance neg parameter in a similar way. After changing the parameters, restart the program. This function 3 is completed. The actuator can rotate with near zero friction and recognize and counteract the no same weight of the load.